In this tutorial, we're going to be looking at the nomenclature of acids and the nomenclature or the naming system of polyatomics. So let's look at acids first. Now, our acids must contain hydrogen. When we're looking at our acids, its naming scale goes per the number of hydrogens. You have two categories with naming acids or the nomenclature of acids. Our oxyacids, which contain an oxygen, meaning they have a polyatomic, or our binary acids, which just have two elements. You'll also see in our binary, a lot of times HCN will be considered a binary because it does not have that oxygen. So the number of H's for an acid is equal to the amount of the charge on the polyatomic. So number H's is equal to the charge of your anion. Now, if we look at these examples, we have SO4 minus 2. So how many hydrogens will we have? We look at the charge, we're going to have 2. So it's going to be H2SO4. Now let's name it. Since it's an oxyacid, you do not use the prefix hydro. You'll look at your anion and then you'll look at the ending. Since this is sulfate, our 8 goes to ic. So I'm going to write this right on the top. For nomenclature of acids, 8 will go to ic. So we have sulfate. Now it's not going to be sulfic because the root word of sulfur is what we're going to use. So this is going to be sulfuric acid. That one was kind of tricky. Now if we look at our next example, we have NO3 minus 1. So we're going to have nitrate. We had the same ending as we did before, but we have only one here. So how many hydrogens do we need? We just need one, so it's going to be HNO3, and nitrate will change to nitric acid. Now, if we look on the opposite side, we have SO3 minus 2. SO3 minus 2 is sulfite. Now, with our acid nomenclature, when we have ite, it will go to us. Still not having any prefix. So we're going to take our anion and we're going to change the ite to us. The same thing as the root word for sulfate and sulfite is sulfur. So this would be sulfurous acid. Now its charge is 2, so we're going to have 2 H's and then we'll have the root anion behind it. So SO3. Same thing we're going to do for NO2 minus, so that's nitrite. We're going to change the ite to us, so it's going to be nitrous acid. We look at the charge, it's a -1, so we're going to have 1 H per NO2 group. Now that's for an oxyacid, meaning that it has oxygen. Now let's look at a binary. Binary, like a bicycle, has 2 wheels. Binary, as our compound, has 2 elements. Now it's going to be different than our oxyacid. Our binary is going to have the prefix hydro. We'll take a look at what we have is chlorine, but it's not going to be hydrogen chloride. Since it's an acid, the ending of your anion is going to go to ic. So it goes hydro, stem of whatever element you have, and then ic. So this one would be hydrochloric acid. So let's look at our next one. We have HF. We classify it as binary, so it's going to be hydro. The stem is fluor for fluorine, and then its ending goes to ic. and then add the acid there. Now that's acid nomenclature. Now let's look at nomenclature of polyatomics. Now polyatomics is related to how many oxygens are present. Now we're going to look at just the nitrate right here. We notice that our nitrate is our NO3 minus 1. I like to start as our 8 as our starting point, or the middleman between adding oxygens and taking away them. Now our nitrate, if we add 1, it's like it's getting hyper, it's having more of our oxygen. So it's actually going to change its name to per-nitrate. Notice how the ending did not change, but you just added the per in front of it. Now, when we lose an oxygen, so we become NO2 minus, we're going to change the ending, so it's going to become nitrite. And if we go to the lowest level of oxygens, it's going to have now a prefix. So we have NO minus. It's now going to be hyponite. Look above, trite. And that's how you look at the naming for all the different species of a polyatomic. Okay, note how the charge did not change. So that's very important that the charge did not change. The only thing that was changing in our name was just how many oxygens were present. Thank you for watching Nomenclature of Acids and Polyatomics, and hope to see you at the next tutorial.